All right, let's roll. Let's do trapezoid rhombus today. Trapezoid rhombus. Quickly review, go look back in your notes if you have to from yesterday. Area of a trapezoid. Trapezoid area. This is probably the toughest one. It's the longest one anyway. 2, whenever you're ready. Area is?
1/2 height times base length plus base.
There we go. I take my bases, I add them, and multiply it by height times 1/2. Good work. And then how about my rhombus here? Area of a rhombus. 9. 9. 9.
1/2 of the percent diagonal second diagonal.
Make sure we're multiplying the diagonals. Please make sure we're multiplying the diagonals and multiplying it by 1/2. All right, good. All right, good work. All right, let's read through number 1. Here you go. Let's read through number 1. So we're talking about a rhombus, right? 1/2 D1, D2. D represents the diagonal length. Where can I put in the 6 here? It gives me a number 6. Where do I put that one in here? 18, where can I put the 6?
Diagonal.
Yep, one of the diagonals is 6. What about the 48? Where am I putting that 48 into? 12? Area, so it should be going over here, 48. And we're looking for the other diagonal. You can call it D2, you can call it X, whatever floats your boat. I'm not going to take this for granted. How do you solve for X? There's a lot of different moves you can make here. What's your move to solve for X? Well, your first move anyway, out of a couple, but what's your first move? 15, your first move. What do you want to do? I got to do something with the 1/2 and the 6 to get X by itself. Okay, that's fine. Do 1/2 times 6. Did anybody think they want to multiply by 2 to get around the 1/2? That's fine too. All right, but yeah, we can multiply 1/2 and 6. 1/2 of 6, 3. So I get 3x. Or if you multiplied by 2, you get 6x equals 96. Fine. Fine. And then from here, I don't think we need to talk about what's next. And what are we getting? 16 feet for the other diagonal. All right, all good? Before I hit up example number 2, let me go over a few properties of a rhombus because we're going to need those to help us. All right, before I answer example 2 here, I need your help. 3 properties of a rhombus. There's more, but 3 properties that'll probably help us out to finding the area. Zach, 1?
Yeah. Inside angle that the 2 diagonals from right angles.
Diagonals are perpendicular. Good. Diagonals perpendicular. Anything else you might remember from rhombus? Romeo. All sides congruent. That'll help us. And there's one more property. And here's a hint. It's a parallelogram too, remember. So whatever a parallelogram has, so does the rhombus. Think you got it?
Diagonals bisect each other.
Each other, yes. Diagonals bisect each other. There you go. There's more, and we'll review them come Regents time, but these are the 3 that'll help you out here finding the area. All right, good review. Now let's find the area. Without doing very, very much work at all, what's one diagonal length? They bisect each other. What's one diagonal? We're going to have more work to do for the other one, but what's one diagonal length already? 16, 80, 40, double 40. You get 80. Good work. All right, you ready to work for the other diagonal? Zach said diagonals are perpendicular, so that's a right angle. They bisect each other, so 40, 40. Thoughts on how I can get the other diagonal now? Here we go. Got to find the other diagonal right here. Thoughts? What are you thinking about? 10, not here. 11, Pythag. Yep, we're going to do Pythagorean theorem here to find the other diagonal. Well, not the full diagonal. Let's say that. A squared, B squared equals C squared. Where are you going to plug in the 40 and the 50? Talk to me. 8, where are you plugging in the 40 and the 50?
40 squared plus b squared equals 50.
Good. 50 is the hypotenuse, so put it in for C. All right, everyone, go ahead. I'll give you a second to solve for B. What'd you get for B here? George?
30.
30, yes. Now, plug 30 into the formula. That's only half, right? Good, good. So I'm going to plug 60 in. Plug 60 in. Remember, 30 is only half the diagonal that you found. Only half. What we got? 2,400 square inches. Make sure we're doing area, so it's square units again. All right, you feeling all right about that? All good. All right, let's go trapezoid now. Trapezoid. Let's get the formula down first. 1/2 height, B1, B2. All right, let's talk here. Height. Remember the height of a triangle yesterday? Comes from a vertice, forms a right angle on the opposite side. Probably a good idea because I don't see a D. AD is a height, but there's also another height we can draw in from B. All right, let's draw in. Well, first, let me back up. Before I start talking about the height. Can I put the 6 and 11 somewhere? All right, let's start there before I get the height. Can I put the 6 and 11 somewhere? 16?
Yep.
Where?
In the B1 and the B2.
Okay, yes. 6 plus 11 in for the basis. Done. All right, now let's talk about the height. Here, AD is a height, but I can also draw one in from B. So let's take B, make a right angle to the opposite side. What type of triangle we just formed? All right, we got practice with this yesterday. 45, 45, 90. Except, here's the difference. I don't know a side in the 45, 45, 90. Look. I don't know BC. I don't know this side length. I don't know the height. Can you find me a side length, please, in the 45, 45, 90? Find me a side length. 3. Can you help me out?
Isn't the height or 6?
6 here. Right? What was DC? So what's the side? 5. Everyone see how we got there? Is a 5 the leg or hypotenuse? Is that 5 we just found a leg or the hypotenuse? 8? Leg. What about the height? And another leg. And if I'm dealing in a 45, 45, what do we know about the legs? There we go. Height's got to be 5 because they're both the legs. Everyone all good? $42.5. And this is what I was talking about yesterday. No units, you can leave it naked. I'm not a big fan of that U squared business. Just leave it naked. And then how about B? Can I use the 7 and 11 anywhere? 7 and 11? 11? Huh.
You can subtract 7 from 11.
Whoa, 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 just in the formula.
Oh,
Don't be a superstar here.
Yeah, you can add them together.
Good. Those are my bases, 7 and 11. Same thing as the last trapezoid. I do have SR as a height, but I probably want to draw one in from P as well. $30, $60, $90 now, right? $30, $60, $90. Can you find me a side in that 30, 60, 90, please? Can you find a side length in the 30, 60, 90? Let's talk 11 again. Zach, now you can be a tough guy.
Now you can subtract the 7.
Yep, 7, 7. 11 minus 7, that's going to be 4. So relax. For the shorter, longer leg, or the hypotenuse? What's 4 in that diagram? Shorter leg, longer leg, hypotenuse. Where are we? 8, where are we? Shorter leg. And is the height the longer or the hypotenuse? 15, height, longer or hypotenuse?
The height is longer.
So what do I do with the shorter leg then?
What if you times radical 3?
There you go. So the height's going to be 4 times radical 3. And then your directions at the top are nearest 10th, right? .62 point. That 5 rounds it up, right? To a 4. I'm going to skip the next problem because you're going to do that with yourself or with other people around you at the end of class. Hold on, though. Hold on. Before I leave the trapezoid here to our last problem. Hey, it's no excuse if you blank on the formula. Let's say you blank on it or you're not confident. What can a trapezoid be broken up into? Rectangle and right triangle. So remember that. If you ever blank, you can always divide a trapezoid up into a rectangle and a right triangle. All good? All righty. Last one I want to do, and then you got Amelia's pennant on your own. We didn't talk about this yesterday. Every single time we did a problem, it was 30, 60, 45, 45. What if it's not? Okay? What if it's not? So this is going back to parallelogram yesterday. This is a parallelogram. So we're doing base times height. So this is a little bit of review from yesterday. We're going to do base times height. Can somebody at least tell me what I know we don't have the height, but can somebody at least tell me where the height's drawn to? A base of how long? Talk to me here. 17, what's the base here? Do we have one here today or no? One of the 17's not here. 12, where's the base? 12, look at that, convenient. All right, you ready for the height now? It's not 30, 60, or 45, 45, is it? But it's still a right triangle. And I can always rely on what if it's a right triangle? Not Pythag, you don't have enough information. Don't say Pythag. Sine, cosine, tangent. Okay, I can use sine, cosine, tangent to find my height here. You'll have to do, I think, one problem tonight like this, where you got to use sine, cosine, tangent. Hey, all right, let's go. From the 35, what's the 4? Opposite, adjacent, hypotenuse. From the 35 degrees, what's the 4? Opposite, adjacent, hypotenuse. What do you got for me? 12 again. It's opposite. And how about the height? Hypotenuse or adjacent? Hey, 14, hypotenuse or adjacent? Adjacent. Let's take a look at our SOHCAHTOA. If you have adjacent and opposite, which one of the three ratios can you use? 5?
Tangent.
Tangent. Let's do it. Tangent of your angle, 35. Opposite, 4 over adjacent, x, or in this case, our height, h. And you guys remember we put this over 1 and crossed our multiplied. So let me do that with you. Tangent of 35 times h equals 4. And then hopefully everybody right now is dividing both sides by the tangent of 35. And you guys have a long decimal staring you in the face, right? Don't even think about it. Don't even think about chopping it up. You plug that whole thing in to the formula and multiply it by 12. Don't even think about it. Nearest hundred, ooh, 100th. I'm really racking it up here. 100th. 1700th. That's right. That's it. We're done. 300th.
68.55.
No, you're right. Calculate. If anybody, by the way, if anybody got 101 like I did, change your calculator to degree mode. One job. Make sure you're in degrees. What do you got?
Yeah, I got
68.55 square yards. Questions? All right. Hey, if you want to work with people around you, that's fine. This Amelia Pennant question doesn't seem like much when you look at it, but it's the real deal here. All right. Find the area of her team's pennant. If you think you have it, call me over, and then I'll let you go to the homework. All right. We're not going to do this one as a class. All right. So if you think you have it, let me know. I'll be around real quick.